Ray diagrams are useful for understanding how lenses work with light. While many rays of light travel through the lens at many angles, 3 rays are especially easy to trace. In a converging lens, the first ray is called the parallel ray. The parallel ray moves from the object to the lens parallel to the principal axis. At the lens, it is bent to pass through the far focal point. The central ray moves from the object to the center of the lens and continues on a straight path. The focal ray passes through the near focal point and is bent at the lens to travel parallel to the principal axis. Any 2 of these rays give enough information to locate the image. The image appears if a screen is placed at the location where the rays converge. With a diverging lens, the parallel ray moves parallel to the principal axis and then bends at the lens. It bends away from the principal axis as though it had originated at the near focal point. As before, the central ray moves from the object to the center of the lens and continues on a straight path. The focal ray begins at the object and is originally aimed at the far focal point. However, it bends at the lens to travel parallel to the principal axis. All of the rays appear to have come from the location of the image. When an object is moved relative to the focal point of a converging lens, its image changes. If the object is infinitely far away, the image will be an infinitely small point image at the focal point F. If the object is at a position outside of 2F, a real image will appear between F and 2F, smaller than the object. If the object is at position 2F, the image will be a real image at 2F. The image will be the same size as the object. If the object is at a position inside 2F but outside F, the image will be a magnified real image outside 2F. When the object is precisely at the focal point, the rays do not converge at all. If the object is inside F, a real image will not form. Instead, a virtual image appears. The light rays seem to have come from a larger image that is further away from the lens than it actually is. A diverging lens can produce only one kind of image, a virtual image. To locate the image, start with a ray parallel to the principal axis. Since we know this is a diverging lens, it is easy to remember that this ray is bent outwards as though it originated at the focal point on the left. Draw a second ray that passes straight through the center of the lens. The image appears where the 2 rays appear to have originated. A magnifying glass is a converging lens and is an example of a simple magnifier. When an object is placed just inside the focal point of a lens, a magnified virtual image appears on the same side as the object. The size of the image of an object formed at the retina of the eye depends on the angular size of the object. As a person moves closer to a house, for example, more and more detail becomes clear. What a simple magnifier does is enable the viewer to examine a small object by producing an enlarged image that fills a larger angle of the observer's field of vision. Less of the object is seen, but it is seen in greater detail.